Okay, so let's now look at a couple of examples. Okay. Suppose test scores are normally distributed. Okay. Let's say we have a sample of 15 scores. So the scores for 15 students with a sample mean of 80.37 and sample standard deviation of 8.68. Let's construct the 80% confidence interval for the population mean. Okay. So let's first identify what we know, right? Let's call test score X, okay? So then we know that we have a sample of 15, right? With a mean of 80.37 and a sample standard deviation of 8.68. We want to go ahead and find the 80% confidence interval. So our confidence level is 80%. The confidence coefficient is 0.8, and so alpha is 1 minus 0.8, which is 0.2, right? And so alpha over 2 is going to be 0.2 divided by 2, which is 0.1. Okay. And here we have a sample of size 15, so our degrees of freedom is equal to n minus 1, which is 14. Okay. So applying the formula, the 80% confidence interval is equal to x bar plus minus t sub 0.1 with 14 degrees of freedom. So 0.1 comma 14 times sx divided by the square root of n. Okay. So plugging in numbers, this is 80.37 plus minus, let's leave the t quantity for now. We know that the sample standard deviation is 8.68, so that's 8.68 divided by the square root of n, which is the square root of 15. Okay, so now we want to find t sub 0.1 with 14 degrees of freedom. Okay, let's go to our t table. Okay. So we look for t sub 0.1 with 14 degrees of freedom, right? So we look at row labeled 14, okay? And then we look under column 0.1, which is this column, okay? That gives us a t value of 1.345, okay? So let's go back here. This is going to be equal to 1.345, okay? And I'm not going to do the math here, but if you do the math, this is 80.37 plus minus 3.01 and so you end up within the interval from 77.36 and 83.38. Okay. Now the two important points that we mentioned earlier apply, right? So first off, the interpretation. Okay, is that we are 80% confident that the mean test score is between 77.36 and 83.38. Okay. Okay. Now, remember the second important point we mentioned earlier was that this formula only works if we have the sample mean being normally distributed. Okay. In this case, X bar is normally distributed. Why? Because even though we have a small sample size, so if n is equal to 15 less than 30, the original variable is normally distributed. Okay, that was given to us in the question.